So on 3.6, it says, hey, we need to take higher order derivatives, which we're used to seeing. We're used to seeing, oh, y prime, f prime, dy dx, the derivative of f of x. These are all what we're used to seeing. Do you think that we could do it again and take a second derivative? We sure could. Anyone have any idea what we'd call this one? If this was y prime, double prime, and f double prime. And this is just the second derivative. Guys, why is the squared after the d here and after the x there? I have no idea. I've asked, yeah. How high? So on this one it said, hey, here's this function, 2 times the secant of x plus e to the x, and it says go find that second derivative. So in order to do that, we just start with the first one. Let's start with the first, and then we'll do a derivative again. What's the derivative of 2 secant of x?
2 secant tangent.
Yeah, 2 secant of x, tangent of x. Very good. Plus the derivative of e to the x.
E to the x.
We love e. And then we've got to go do that again. Since they said find the second derivative, we're going to say, okay, the second derivative is, and when I look at this, what rule do I need to apply? Product rule. Well said. She's like, oh man, this is really a secant times a tangent. Yeah. Whew, here we go. F prime. What would F prime be? Right. That's really where we just started right there. F prime is going to be 2 secant x tangent of x. That right there was F prime. That we need to multiply times g, which is another tangent of x. Correct me if I'm wrong. And then we got to go add gift to that, g prime. Derivative of tangent of x, secant squared of x. So I'd get a secant squared of x there. That's my g prime. And then we got to multiply that by f, which was 2 secant of x. And don't be forgetting those x's. These x's are muy importante. Oh, jeez. Guys, thank you. We got to do the derivative of e to the x again. What's that going to get me?
E to the x.
E to the x. So yeah, we had to remember, take the derivative of that e to the x again. This one says, hey, go find the second derivative of f of x is 8 times the sine of x divided by 2. Biscuit might leave this as x divided by 2, but how could Biscuit rewrite this instead of x divided by 2? 1/2 x is going to make our lives a little easier. Okay, here we go, y'all. We got to go find that second derivative. So I'm going to put the first derivative. I'm going to say f prime is my first derivative. What's the derivative of 8 sine of 1/2 x? 8 cosine of 1/2 x. Times, what'd you say? Perfect.
So that's 4 cosine.
Exactly. If I were you, I would simplify this before I go do a derivative again, just to get less things around. So, Coop, you're saying 8 times a half is actually 4 cosine of 1/2 x. Biscuit, you know I'm just picking on you because I can. But if Biscuit would have left this as x divided by 2 right here to get the derivative of that inner, he would have done quotient rule. All right, guys. The second derivative we're going to say is called f double prime. Whoa. Second derivative of x, thanks, buddy, is going to get us what? The derivative of 4 cosine would turn into... Nice, because the derivative of cosine is negative sine. You're like, that 4 is hanging around. So we'd have a negative 4. Negative 4 sine of 1/2 x times 1/2. And again, that's chain rule, you guys. The derivative of the outer we left the inner, times the derivative of the inner. My final answer could just be left like that, or we could multiply the negative 4 times the half to get a negative 2 sine. And could I even go back to x over 2? For sure. For sure. And maybe you don't even have to rewrite it as 1/2 x to know that the derivative of this is just 1/2. That's fine too. Okay, this one, they're getting ornery on us now, you guys. Find the second derivative. Don't get stuck on the second. Let's just do it one at a time. So let's go find the first derivative first. But there is just like some y's floating around. Just be careful. Derivative of y squared would get me 2y dy dx. Good job. Derivative of 7y. 7 dy dx. Well done, Mar. Derivative of 4x. 4. Now, they said go find the second derivative. So we have to go do that again. But my piece, what I think is easier is go get your dy dx by itself before we go take a second derivative of that. So let's go get dy dx by its lonesome. So are you cool if we subtract 7 dy dx just to get my dy dx's on the same side? Factor that dy dx out. And then go divide it out. So this is the first derivative. They want the second derivative. We got to go take a derivative again. Ew. Okay. The derivative of dy dx is that d squared y over dx squared. That just means, hey, I'm taking the second derivative. So I'm going right here. Boom. Second derivative. If you just wrote y double prime, that's fine too. That's fine too. Okay, what rule do we need to do here? Quotient rule. Let's go do it. What's my low? 2y minus 7. D high. 0. Low D high minus high. And then be careful on that D low. 2 dy dx. Oh, yeah. And then the 7. So I'm just going to make myself a little bit more room. 2 dy dx minus 0. So just 2 dy dx. Love that, Beck. Thank you. All over.
Low squared.
Low, low. You guys, you took the second derivative. Here's the thing. We can't leave this dy dx there. Everything else is cool to stay. Technically, wouldn't this just be a 0 over here, you guys? What do you think I could replace this dy dx with? Ooh.
Oh.
Isn't dy dx the same as 4 minus 2y minus 7? That's why I got dy dx by itself first. So my second derivative is, I'm going to get rid of that 0, negative 4 times 2 times 4 over 2y minus 7 all over 2y minus 7 squared. And let's just be done there. Let's just be done there. If you wanted to simplify, these are technically over 1. So I would technically have negative 4 times 2 is negative 8 times 4 is negative 32 over 2y minus 7 over 2y minus 7 squared.
And then you can multiply by the reciprocal.
Yeah. 2y minus 7 would technically be multiplied by 1 over 2y minus 7. You guys do not need to do this, but what would that answer be then, Coop? 2y minus 7 to the what on the bottom?
Cubed.
Yeah. Whoa.
Which is way too much.
Yeah, you guys, we can end right here. But I just wanted to show that to you. It's something to really make our brains sweat on this Thursday morning. Something else I wanted to point out there. Is anyone back at this step like, man, I know Biscuit likes the quotient rule. Just kidding, Biscuit, I'm putting words in your mouth. Could we have rewritten this to do it a different way?
Probably.
Again, you don't need to write this down. But could I have, I just like showing this. Yeah. Could I have said, hey, my derivative is 4 times 2y minus 7 to what power?
-1.
To the negative 1. Could I have done that? Are these equivalent?
Yeah.
They are. Then that second derivative, again, you don't have to write this, would just be doing power rule. And that'd be a negative 4, leave the inner, take my exponent down by 1, times the derivative of my inner. Derivative of my inner? 2 dy dx. Would I have still had to go, substitute this quantity in right there. Yeah, again, you don't need to write this down. I just wanted to show you. 2y minus 7 to the negative second times 2 times 4 over 2y minus 7. And would this answer be equivalent to this answer? Yes, it would. Because this 2y minus 7 would go to the bottom, so I'd have 3 of them down there. And 4 times 2 times negative 4 would get me my negative 32. I only say this just to give you options. If Henry's like, dude, I'm here for power rule all day, every day, he can do it. Biscuit's here for quotient rule, he can do it. Both of them, I don't think one way is easier than another, honestly. Maybe this one was actually a little easier, but you got to remember that step. It's up to you. Find the second derivative of an inverse tan. OMG. Let's just worry about the first derivative. Let's just worry about f prime. Inverse tan is one of our new rules, but it's my favorite rule because it's 1 over 1 plus that angle squared. But what goes in those parentheses? Good job, Eve. We need a 2 because that 2 is the chain rule. The derivative of the inner got us a 2. That's the first derivative. I personally, if I've got to do this again, I'm going to go rewrite that as 2 over, 1 plus. Let's simplify this thing to make our lives a little easier. 2x times 2x would get me 4x squared. Question, do you want to go quotient rule, which we can, or do you want to practice what we just did and say, if this is all to the first down there, I want to bring it up and make it to the negative first? Why don't we try that? I feel like we're good at quotient rule, so let's try something different. Let's go rewrite this. My first derivative is 2 times 1 plus 4x squared to the negative first. I'm going to get rid of what we had over here. That's still my first derivative. I just rewrote it. I just moved that denominator up. One more time. This is the first derivative. Let's go do that power rule. Let's go do that power rule now. And we'd say, all right, my second derivative, f double prime, is what? Bring that exponent out front. We get negative 2, leave the inner. 1 plus 4x squared to the negative 2.
Times 4x.
Times the derivative of the inner. Careful, what's the derivative of that inner? Wouldn't it be 8x, bud? Oh, yeah. Oh, yeah.
Oh, yeah, 2x squared would be 4x squared.
What could that be? Would this be the same as negative 16x on top and 1 plus 4x squared to the tooth on the bottom? Bringing it down makes my exponent positive. We could have ended right here. Bob's definitely ending here. Oh, that's probably what. What?
I did.
Let's just try 17 and we're done. I'm not even going to assign homework on this because this one's a new thing. It says, hey, here's this function. What are they asking for here in only terms of symbols? They're asking for the second derivative. Well said. And we'll worry about that point later. Let's go find the first derivative. Whoo, first derivative. Notice how much space I left you? It's because there's a lot of work for this. Derivative of x squared? 2x. Be careful. Derivative of y squared.
2y dy dt.
Good job, you guys. Derivative of 25?
0.
0. You guys, we could go take the second derivative right now, but we're going to have to get our dy dx by itself eventually. So go get your dy dx by itself now. Let's go do that. So we got 2y dy dx equals negative 2x. Yeah? Okay. Then we're going to divide by my 2y. And what would we say dy dx equals? I would simplify it as much as you can. Yeah, because we're going to have to take a derivative of it. Those 2's will cancel, and I'm left with negative x over y.
But you can make negative x times y to the negative first.
For sure. If you did that, Coop, what rule do you have to do when you take this derivative? Product rule, okay? I personally think quotient rule is easier in this case because I feel like we mess up with my negatives, but I'm down with whichever. Would you guys rather go quotient rule or product rule? I don't care. Quotient, we're going biscuit style. Biscuit. Quotient rule, here we go. Second derivative. What's my low, y'all? Love it. D high. Very good. Low D high minus high. My high was a negative x. So if you just wrote plus x there, great, because it's minus the high. Low D high minus high. D low, be careful. Dy dx, good job. All over low, which would just be a y squared. You guys, they want us to go plug in the point 4, 3. Before I plug that in, I've got an x for a 4, I got a 3 for a y. What can we put in for our dy dx? Yeah, exactly. Can't we go put in my negative x over y? Or what'd you say, Lob? Close. Wouldn't it? Oh, yeah, it would be negative 4/3. He put in that x is 4 and my y was 3. So that's going to be a negative 4/3. Agreed. I love that. So I'm going to simplify before I plug in. You guys are welcome to plug in right now. I'm just going to simplify to see if I can make things a little easier for people to visualize. But again, if you don't need it, please carry on. Carry on my way, do. Then I'm going to plug in the point 4, 3. If my y was, I'm going to get a negative 3 plus my x is 4 times, like Lobley said, a negative 4/3 over my y cubed, my y squared, which would be a 9. Ooh, this is multiple choice, so we have to simplify it. Did I make a mistake yet? I hope not. So I'd say I get negative 3 minus 16/3 over 9. It's kind of gross, and if you're struggling with it, I personally would get common denominators up top. Negative 3 to have a thirds would be the same as negative 9/3 minus 16/3. Whew, I didn't even give myself enough room. Negative 27/3. No. Negative 25/3. Thanks, guys. Divided by 9 is the same as negative 25/3 times 1/9. Then I'd multiply across. And is that an answer? Whoa. That was from 1997. Hopefully they don't do, that was insane.